All right, we are now in the next unit. Unit 4 is geometry. And in this unit, there are two modules, modules 8 and 9. Today, we are going to do module 8, and we're going to begin with the lesson 8.1. Here is your module 8 packet. Module 8 is called Modeling Geometric Figures, and we're going to be working on lesson 8.1 today, which is called Similar Shapes and Scale Drawings. All right, 8.1, Similar Shapes and Scale Drawings. So scale drawings and proportions. In the ratios and proportions unit, you learned how to solve proportions. We are going to use that skill that you learned in the ratios and proportions unit to solve problems with scale drawings, okay? So the first part is called scale drawings and proportions. So first of all, a scale drawing is a proportional two-dimensional drawing of an object. So a good example is sometimes they'll make a scale drawing of a new building. They're going to build a new building and they'll make a little model of it. And that model is a scale model because it is proportional to what the real building will be. A map is also a good example. A map is a scale drawing of like a neighborhood. The map is to scale, which means it's proportional to real life. Okay, so scale drawings can represent objects that are smaller or larger than the drawing. So like a drawing is a smaller version of the neighborhood, right? Sometimes you'll have a scale model, like a model car is a smaller version of a real car. But sometimes like they'll make models of like insects, like a little tiny ant. They'll make a giant model of it so you can see it better, you know, if you want to like study it or whatever, right? So they'll make a big scale model of an ant, but the scale model is actually larger than the real object. So scale drawings and models can represent objects that are smaller or larger than the drawing, okay? So models would be three-dimensional, but drawings are two-dimensional. So let's talk about the word scale, okay? The scale between a drawing and the real-life object is a ratio, okay, between the two sets of measurements. So scales are usually written like this. So you'll see on a map, it'll say something like 1 inch, and that's the ratio symbol, and then it'll say like 5 miles. What that means is 1 inch on the map is proportional to 5 miles in real life. Okay, so let's use scale to find length, width, and area. Okay, so this picture right here, okay, it says this picture is a scale drawing of a wall. So this is a picture, but it is a scale drawing of a wall, like a mural painted on a wall. Okay, so use the scale to find the area of the actual wall. So here is how I do this. I do it just like I taught you in the ratios and proportions unit. We're going to write 3 ratios. We're going to write the word ratio, and then we're going to write the given ratio, and then we're going to write the missing ratio and solve for the missing part. Okay, so step 1, we're going to find the length of the real wall. So the length of the picture is right here. We're going to do length is 28 inches, okay? But here's the scale right here. We're going to use this scale as our given ratio. So the word ratio when you're talking about scale drawings or scale models is what I do like drawing compared to real life. So that's what we're comparing, the drawing or the scale drawing compared to the real life wall, the wall in real life. So the given ratio is right here. It's 2 inches on the drawing. 2 inches is 3 feet in real life. So you can put the units as well. That is the given ratio, the scale. Then what we want to know is what is the real life length of the wall if the drawing is 28 inches. So drawing, all the drawing numbers stay on top, 28 inches, and you see that right there, 28 inches. And real life, we want to know what is the real life length. So we know that we can use our calculator, and the way we solved proportions before, when we had the ratios and proportions unit, is we're going to multiply the 3 times 28, 3 times 28 equals, and then we're going to divide by that third number, divided by 2, and we get 56. So in real life, it's 56 feet. That's the length, okay? Now we're going to find the width of the wall, all right? So we're going to do the same thing. I'm going to do D for drawing, and I'm going to put R for real life, 2 inches compared to 3 feet. So that's my word, that's my given, and here's my missing. Now this is the width right here. The width equals 11 inches. So the inches go on top. So I put 11 here. So what is the width? Again, I'm going to do 3 times 11. 3 times 11 is 33, divided by that 2, and I'm going to get 16.5. So 3 times 11 divided by 2, and I get 16.5 feet. Now to find the area, area equals length times width, right? So I'm going to do 56 times 16.5. So 16.5 times 56, and I get 924. 924 feet squared. That is the area of the real wall that this picture represents. This is a scale drawing of a mural on a real wall. And what the question was, what is the area of the actual wall? So to find that, we find the length of the real wall, the width of the real wall, and then we do length times width, and that gives us the area. All right, so we're figuring out how to find length, width, and area when we have a scale drawing and we know the scale. All right, so on the next page, we're going to actually find the scale. So what if you know the dimensions of the two copies, like the real object and the drawing, but you don't know the scale? Okay, so a scaled copy of a figure is created by multiplying each length in the figure by the same number. That number is called the scale factor. Okay, factor is a number in a multiplication problem. You're multiplying the scale factor times each side to get the new side. Okay, so here's an example. This says polygon S is a scaled copy of polygon R. So this is polygon S. This is the original polygon. We scaled this one to make this one. Okay, so this is the first one. This is the new one. All right. Then it says what scale factor takes polygon R to polygon S? How do we get from this one to this one? All right, from R to S. So here is what you do. Number one, you find two corresponding sides. What does that mean? You want to find two sides that go together on the drawings, okay? So this side, for example, right here, corresponds with this side right here. Those are corresponding sides, okay? So we first find two corresponding sides, which we did. Then we're going to write an equation to solve for scale factor, because that's what we're trying to find. We're trying to find the scale factor. Well, we know that each of these lengths was multiplied times the scale factor, and that gives us our new length. So the side length times the scale factor, and that's what we're looking for, is the new side. So we're going to say, let's say this is A, side A, and when we have a new drawing, we call this side A prime. That's what we call it. See that little 1 underneath it? That's called prime. So we go from A to A prime. If this side was B, we'd we'd have B here and B prime over here. If this side length is C, this would be C and this would be C prime over here, okay? So what we're going to do is we're going to go A times the scale factor equals A prime, okay? So A is 45 times the scale factor equals 27. There's our equation. 45S equals 27. So now we can solve to find the scale factor, right? Because 45 times S, how do we reverse multiplication? Oh, you can't see what I'm doing. How do we reverse multiplication? We divide, right? So I'm going to divide this by 45 and divide this by 45. Those cancel. And S, I'm going to go off the page a little bit here. S is equal to 27 over 45. Well, that can reduce, okay? 9 can go into both of those. So I'm going to simplify it as my last step. I'm going to divide this by 9, divide this by 9. 27 divided by 9 is 3. 45 divided by 9 is 5. So the scale factor from R to S is 3 to 5. You could write it like this, 3 to 5, right? That's how we wrote it on the map. But this is the scale factor from R to S is 3 to 5, okay? 3/5. It's a 3/5 factor. All right, that is finding scale factor and finding length, width, and area using scale factor, and that is 8.1, our first lesson in the geometry unit.